it the Higgs boson? Three-dimensional spiral string theory, 3D-SST, developed in 2006, offers an alternative explanation of the nature of the new particle, which discovery by the Large Hadron Collider experiments was officially confirmed in 2013. What was the purpose of the experiments? According to the standard model, the proton is made up of three quarks, two up U quarks and one down D quark. The total mass of these quarks, however, accounts for only 1% of the proton measured mass. The purpose of the experiments was to discover the Higgs boson, a particle presumably providing the proton with the missing 99% of its mass. Where is the remaining mass of the proton coming from? According to the model developed in 1960s by several physicists, including Peter Higgs and Francis Englert, the proton gains its remaining mass by interacting with the Higgs field that permeates all space. The mass is transferred from the Higgs field to the proton by a Higgs boson with the process controlled by the Higgs mechanism. During the experiments, the protons travel in opposite directions inside the accelerator at speeds approaching the speed of light before they are made to collide at two particle detectors, the ATLAS detector and the CMS detector. Because the lifetime of the new particle is too short to be detected, its mass was determined based on measured parameters of its decay particles, photons and leptons. The average masses of the new particle measured by the CMS and ATLAS groups were respectively 125.3 and 126.0 giga-electronvolts, or 133.5 and 134.3 times greater than the proton rest mass. How close were the predicted and measured masses of the new particle? According to the data published by the Particle Data Group in 2006, various theories predicted that the lower mass limit of the Higgs boson shall be from 84.5 to 121.9 times greater than the proton rest mass. But these theories did not predict the mass upper limit. The 3D-SST predicted in 2006 a single value for the relative mass of the new particle that was 136.9 times greater than the calculated proton rest mass. This value turned out to be within 2.5% of the measured relative masses of the new particle. Both groups concluded that the results of their experiments were consistent with the expectations for the standard model Higgs boson, but with some reservations regarding to the nature of the new particle. According to the ATLAS group, more data are needed to assess the nature of the new particle in detail. According to the CMS group, the collection of further data will enable a more rigorous test of this conclusion and an investigation whether the properties of the new particle imply physics beyond the standard model. The 3D-SST goes beyond the standard model. According to this theory, at the core of the universe are the toroidal spiral spacetimes called toryces. Based on the same three spacetime postulates, the toryces are applicable to both micro and macro worlds. In the micro world, they are responsible for the creation of all elementary matter and radiation particles. In the macro world, they are responsible for the creation of gravity and black holes. The 3D SST is described in the books Prime Elements of Ordinary Matter, Dark Matter, and Dark Energy, published in 2006 and 2007. The latest version of the 3D SST, called the Universal Spacetime Theory (UST), is described in the book The Spacetime Origin of the Universe, published in 2013. Below is a brief description of this theory. Torix contains three components: double circular leading string propagating along its circular path with the radius r1, double toroidal trailing string with the radius r2 wound around and propagating synchronously with the leading string, and spherical membrane with the radius r embracing the trailing string. Unlike dimensionless quarks and elementary particles of the Standard Model, the torix is visualizable. To the right is a mechanical model of the torix trailing string sitting on a flat mirror reflecting both the torix model and a blue sky. All torix spacetime parameters are derived based on three torix spacetime postulates. First, the lengths of leading string L1 and one winding of trailing string L2 are equal to one another. Second, the torix I radius R0 is constant. And third, the spiral velocity of trailing string V2 is equal to the speed of light in vacuum c. We will show below that these three simple postulates yield amazing properties of torices. Three torix spacetime postulates yield the unified law of planetary motion. This law establishes a relationship between the relative velocity β1 and the relative radius b1 of the torix leading string. Notably, for a particular case when b1 is much greater than 1, this law reduces to the well-known law of planetary motion based on classical mechanics. Transformation of torices. As the relative radius of leading string b1 decreases from positive to negative infinity, the stiffness angle of trailing string phi2 increases from 0 to 360 degrees, producing four kinds of topologically inverted polarized torices: real negative, real positive, imaginary positive, and imaginary negative. Real negative torices are located in the top right quadrant. Trailing strings of these torices are wound outside of the torix eye. In these torices, all mean spacetime parameters are expressed with real numbers. Real positive torices are located in the top left quadrant. Trailing strings of these torices are inverted and wound inside of the torix eye. In these torices, all mean spacetime parameters are expressed with real numbers. Imaginary positive torices are located in the bottom left quadrant. Trailing strings of these torices are inverted and wound inside of the torix eye, while their windings overlap. In these torices, some mean spacetime parameters are expressed with imaginary numbers. Imaginary negative torices are located in the bottom right quadrant. Trailing strings of these torices are outverted and encircling the torix eye. In these torices, some mean spacetime parameters are expressed with imaginary numbers. Harmonic torices are located approximately in the middle of each quadrant. In these torices, the frequencies of their trailing strings relate to one another by simple harmonic ratios. Excited torices change their dimensions as a function of the toric quantization parameter z, that is a function of the exponential and linear excitation quantum energy states m and n respectively. During excitation of torices, their I radii R0 remain constant. Oscillated torices decrease all their dimensions by the toric oscillation factor q sub q. That is a function of the toric oscillation quantum state q. Excited torices are located near border lines between quadrants. Inversions of the toric components occur at all components 0, 360 degrees, trailing string 90 degrees, spherical membrane 180 degrees, and leading string 270 degrees. Physical properties of torices are closely related to their spacetime properties. Toric charge ET is proportional to the ratio of the radii of the toric trailing string R2 and leading string R1 with opposite sign, where E is the elementary charge. Toric gravitational mass mg is proportional to the absolute ratio of the radii of the toric trailing string R2 and leading string R1, where me is the electron rest mass. Elementary matter particles, trons, are formed by the unification of excited polarized torices. This produces four kinds of trons: electrons, positrons, ethertrons, and singulatrons. Toryces exist at different matter levels, defining their excitation quantum energy states M. For the matter level 1 harmonic matter, M is equal to 0 for ethertrons and singulatrons, and M is equal to 1 for electrons and positrons. For the matter level 2 ordinary matter, the respective values of M are 1 and 2, and for the matter level 3 dark matter, the respective values of M are 2 and 3, and so on. Atomic electrons of ordinary matter is made up of one real and one imaginary negative linearly excited torices. When the linear excitation quantum energy state n of these torices increases from 1 to 2, the relative radii of their leading strings enlarge 4 times. When the exponential excitation quantum energy state m of these torices increases from 2 to 3, these radii enlarge about 137 times. At the same time, the electron mass and charge remain unchanged. Nuclear positron of ordinary matter is made up of one real and one imaginary positive, linearly excited torices. When the linear excitation quantum energy state n of these torices increases from 1 to 2, the relative radii of their leading strings get closer to 0.5. The same occurs when the exponential excitation quantum energy state m of these torices increases from 2 to 3. At the same time, the positron mass and charge remain unchanged. Ethertrons of ordinary matter are made up of one negative and one positive real linearly excited torices. When the linear excitation quantum energy state n of these torices increases from 1 to 2, the relative radii of their leading strings get closer to 1. The same occurs when the exponential excitation quantum energy state m of these torices increases from 2 to 3. At the same time, the ethertron mass decreases about 137 times. Singulatrons of ordinary matter are made up of one negative and one positive imaginary linearly excited torices. When the linear excitation quantum energy state n of these torices increases from 1 to 2, the relative radii of their leading strings get closer to 0. The same occurs when the exponential excitation quantum energy state m of these torices increases from 2 to 3. At the same time, the singletron mass increases about 137 times. Harmonic ethertrons are made up of one negative and one positive real harmonic torices. Since the exponential excitation quantum energy state of these torices m is equal to 0, their spacetime and physical parameters do not change with any changes of their linear excitation quantum energy states. Thus, the parameters of the non-oscillated harmonic ethertrons are the same for all matter levels. Harmonic singulatrons are made up of one negative and one positive imaginary harmonic torices. Similarly to the harmonic ethertrons, the parameters of the non-oscillated harmonic singulatrons are the same for all matter levels. Proton is a complex particle made up of a nucleon core and a nuclear positron. The nucleon core is made up of harmonic trons and excited singulatrons and ethertrons, located at the center 1 and the vertices 2 through 7 of an octahedral crystal structure. The nuclear positron is located at its center 1. Calculated proton mass is approximately 4.6% greater than the measured proton rest mass, allowing for the energy to form the crystal structure. According to the 3D SST and UST, the microworld is a conglomerate of entities made up of polarized torices. It follows the unified law of stable polarization, according to which the sum of polarization parameters of all components of a stable system is infinitely small. During various phases of existence of the universe, either the entire microworld or some of its parts appear in the following forms: quantum vacuum, harmonic field, elementary particles, nucleons, and atoms. The quantum vacuum is an extreme quantum energy state of the microworld. It is made up of a singletron surrounded by infinite numbers of ethertrons. Since the masses of the ethertrons in the extreme quantum energy states are infinitely small, the quantum vacuum appears as nothingness. Helices are the prime elements of elementary radiation particles. They are formed when excited torices become de-excited. Helix structure has two levels. The first level is in the form of a single double helical spiral, with each branch propagating along a helical spiral path. The second level includes two double helical spirals, with each spiral wound around one of the branches of the helix first level and propagating synchronously with them. All helix spacetime parameters are derived based on three helix spacetime postulates. First, the wavelength of trailing string lambda 2 is equal to the length L1 of one winding of leading string. Second, the helix I radius R0 is constant. And third, the spiral velocity of trailing string B2 is equal to the speed of light in vacuum c. Similarly to the torics, the above three helix spacetime postulates yield amazing properties of helices. Elementary radiation particles, tons, are formed by the unification of polarized helices. Electrons, positrons, and ethertrons of all matter levels propagate at the speed of light. As the matter level increases, their frequencies decrease. Singulatrons of harmonic matter also propagate at the speed of light, while the singulatrons of ordinary and dark matter propagate at the superluminal speed. As the matter level increases, their frequencies increase. Conclusions based on the 3D SST and its latest version, the UST. First, the proton is a complex particle made up of elementary particles residing inside of an octahedral crystal structure. Second, during proton-proton collisions, the matter level of the excited proton increases from 2 of ordinary matter to 3 of dark matter, increasing its mass about 136.9 times. Third, the excited proton captures an electron and then resembles the new neutral particle discovered during the proton-proton collisions experiments at CERN. And fourth, the experiments conducted at the Large Hadron Collider in 2012 have possibly provided for the first time evidence of the existence of dark matter. The Hiricola Press welcomes all arguments related to the proposed explanation of the nature of the new particle. Thank you.